Definition of the inverse function. Let f and g be two functions such that f composed with g of x is x for every x in the domain of g, and f of g of f of x, this is fog and this is goff, is equal to x for every x in the domain of f. Now what does that mean? That says these two guys get together, form a unit, and you end up where you started out. It's your round trip ticket. It says one takes you from the domain to the range, the other one takes you from the range back to the domain, which means you ended up where you started out. Me to DC, Phoenix to DC, DC to Phoenix. Where did I end up? I ended up where I started out. That's the inverse. That's the inverse of the function. Same thing here. These two guys go together, and I end up where I started out. That says that these two functions are inverses of each other if you end up where you started out under function composition. So we say that f of f inverse of x equals x because they cancel each other out, and f inverse of f of x equals x because they cancel each other out. That says you start out, all it says is, not so much about the variable, but it says you end up where you started out. See, if I look at f inverse of f of x, this is domain, this is range, so this guy f takes the domain to the range. And then once I'm over here, and I don't know where I am, but I'm over here, the inverse is then going to pick up that thing and take me back to where I started out. So where did I end up? I ended up where I started out. Now this one, if I look at f of f inverse of x, that says we're operating first with the inverse function. So I'm starting over here. The inverse brings me back to the domain to something. I don't know what that something is, but it's something. Then the function brings me back. So I ended up where I started out. They cancel each other out. The undo button. The undo button. So we say, suppose f of x is equal to 2x minus 3, and then f inverse is x plus 3 over 2. If I look at f inverse of f of x, that says wherever I have an x, in the inverse function, I'm going to put f of x. So the inverse is x plus 3, so this is f of x plus 3. So you're going to get 2x over 2, or x, so you ended up where you started out. This says in the original function, you're going to stuff the inverse. The original function is 2x minus 3, so 2 inverse minus 3. The 2's reduce out. You get x plus 3 minus 3x. You ended up where you started out. That says these two guys cancel each other out, and what you're left with is that. That's how you know the two things are inverses of each other. So it says, determine whether they are. Well, if we're going to determine whether they are, the determination is that f of f inverse of x has to be equal to x, or in this case, the way they have it set up is that f of g of x has to be x. So if they're two inverses of each other, if I compose f and g, I will end up where I started out, which was x, because everybody cancels out. So f of x is 6x, g of x is x over 6. So f composed with g of x says in the function f, wherever I have an x, I'm going to pull the x out and put in x over 6. So f is 6x. So it's 6x. I replace x by x over 6. The 6's cancel. I'm left with x. And the answer would be, are they inverses of each other? Yes.
Yeah.
Okay? Okay, I want f of g of x to be equal to x. So that says in the function f, wherever it says an x, I'm going to replace it by g of x, which is x plus 3 over 7. So this would be 3x minus 7. So x gets replaced by the inverse, which is x plus 3, or what we think is the inverse, over 7. This ends up being 3 times x plus 3 over 7 minus 7. Need a common denominator, so 7 over 7. So this is 3x plus 9 minus 49 over 7. Is that ever equal to x, ever? Is anything ever going to reduce out so what I have left is an x by itself? No. So this thing is not equal to x. So are they inverses of each other? No. It doesn't verify.